Hey, Algebra 2. We are going to be using what we've been learning in class about writing equations of lines and apply them to some real life situations. Okay? Um, when you're writing these types of situations, I want you to understand that the slope in a real world application, the m, the number in front of x, represents the rate of change. Okay, how fast something is changes. Okay, and where we start, our initial value when x is 0, obviously, is the y-intercept. Okay, so when we write these equations, I'm going to be asking you, what's the slope represent? What's the y-intercept represent? Okay, so for example, let's say you're visiting Baltimore, Maryland, and you want to grab a taxi. Okay, the taxi charges a flat fee of $3 just for getting in the taxi, and then it's 75 cents per mile. Little hint is, as soon as you see that word per, that should kind of alert to you that that's the rate we're talking about. Okay, per mile, 75 cents per mile. That's the rate of change. Okay, it depends on the number of miles. So we're going to write an equation to find the cost of the taxi ride. Okay, we're going to let x be miles and y be the cost. So the cost is, let's see, it's $3 just to get in the cab. And that's the only time, that I pay that $3 once. And then I pay the 75 cents per mile. So it's 75 cents per mile. If x is the number of miles, if I go 1 mile, I pay 75 cents plus the $3. If I go 2 miles, I pay 75 cents times 2 plus the 3 miles. Or $3, I'm sorry. If I go 3 miles, I pay 75 cents times 3 plus the $3. This is the $3 just to get in the cab. Okay? So do you see that 75 cents is the slope? 3 is the y-intercept if I was going to graph this, right? Or I could say 3/4 if you want to change, it's up 3/4. If you want to change this to a fraction, you could always do that. I'm not asking you to graph it, though. I just asked you to write the equation, and that would be it. Okay, the slope represents the cost per mile. The y-intercept, it represents the initial fee, that first, something that just happens once. Okay, when x is 0 miles, I don't even go anywhere. I get in the cab, I change my mind. Oh well, I still paid $3. Okay, how much would a taxi ride for 8 miles cost? Well, now that I have the equation, I can just put 8 in for x, right? Do you understand that? 8 miles, x is the number of miles. So on your calculator, take 0.75 times 8 plus 3, and you get $9. Okay, so I'm not just going to say y equals 9. I'm going to say, the question was, how much would a taxi ride for 8 miles cost? So I'm going to put $9. I'm going to put my answer in a form that makes sense with the question. If a taxi ride costs $15, how many miles did I ride? Maybe I only have $15 in my pocket. So I'm thinking, wait a minute, I got to think about how far I can drive in this taxi. So now the cost, remember, is y. So I have my equation. I'm not going to put 15 in for x, right? 15 is y. 15 equals 75 cents times how many miles plus 3. So now we're going to have to use our algebra skills here that we have. We're going to subtract 3. 12 equals 75 cents times x. I'm going to divide both sides by 75 cents. You can do that in your calculator, and you get 16 miles. Okay, if you take 12 divided by 0.75, you get 16 miles. Okay, so again, notice I didn't just write x equals 16. I'm writing 16 miles. The question was how many miles? 16 miles. Okay, how are you feeling? Does it make sense? I hope so. Let's try this second example. Okay. This time we might use the point slope form instead. I don't have that initial value, maybe, the y-intercept, okay? The math department sponsors a math family fun night. In the first year, okay, we have a couple data points here. In the first year, there were 35 participants. In the third year, okay, second year, we forgot to keep track. Third year, there were 57 participants. Okay, so in the end, I'm wondering, this is the 5th year now, and I want to make a prediction as to about how many people. So I want to have snacks, etc. So I'd like to know. So first we create the 2 ordered pairs, okay? Year 1, I'm going to let X be, they told me to let X be the years, Y be the number of participants. So the rate of change, I'm going to find the slope. 57 minus 35, right? We subtract the Y's, divided by 3 minus 1, okay? So I'm taking 57 minus 35, that's 22. I take 3 minus 1, that's 2. So it looks like my rate of change is 11. Now I need to write an equation. So I'm going to use this one. I know some of you just go right to point slope, but I'm gonna choose this point just because it's smaller numbers. I could choose either point. Y minus the Y value of that point equals the slope times X minus the X value of that point. So I have Y minus 35 equals 11X minus 11. I'll add 35 to the other side and get Y equals 11X plus 24. And now I have my equation. I can use that to predict how many people do I think are going to come on this 5th year? Well, I'll put, remember, X is the year, so 11 times 5. I think, based on my data from year 1 and year 3, that 55 plus 24 people are going to come. I think about 79 people is my estimate. So when I'm buying some snacks and drinks, I'm thinking there might be about 79 people there based on how it's been increasing over from my 2 data points. Okay? Now, if I would have used 357 instead, okay, the only thing would have changed is I'd have Y minus 57 equals 11 times X minus 3. So then I'd have 11X. When I distributed that through, I'd have 33 instead, right? And this, of course, would have been 57 that I was using. So I would have added 57 to both sides. Let's see, 57 minus 33. If I do that on my calculator, oh, what a shocker, I get 24. So, again, it doesn't matter which point you use. Those of you that aren't a fan of point slope form, maybe you went right to Y equals mx plus b, and you use 11 for the slope, and you don't know what b is, but you pick a point. Maybe you picked 1 for x, 35 for y. 11 times 1 is 11. And then you subtract 11 from both sides, and you get b equals 24, and then you rewrite it as y equals 11x plus 24. Okay, so there's so many ways to do it, guys. I am not concerned with your process as long as you pick one that makes sense to you. I prefer point slope form to get me here. Some of you prefer slope intercept form. That's fine. Either way, we get y equals 11x plus 24, and we put 5 in and we make our prediction. All right, here's one that comes out asking for standard form. It just cries out standard form, okay? A fisherman's market has shrimp that sells for $4.25 a pound and halibut that sells for $2 a pound. You have 11 bucks in your wallet and you're supposed to bring some of each home, okay? So we're going to let X be the number of pounds of shrimp and Y be the number of pounds of halibut. To model this equation, I have $4.25 per pound for shrimp. If I have 1 pound of shrimp, it's $4.25. If I have 2 pounds of shrimp, it's $8.50, right? X is how many pounds of shrimp. Plus, it's $2 a pound for the halibut. I don't know how many pounds of that I'm going to buy. That's what I'm asking. I know, though, that when I take 425 times my number of pounds of shrimp plus 2 times my number of pounds of halibut, it better not go over 11. That's all I have in my wallet. This is the equation. Now we're looking, remember, standard form. It's not always slope-intercept. I would like to find the slope of this and figure out what it represents in the context of this problem. So to find the slope, of course, I'm going to subtract the 425x to the other side with the 11, and then divide by 2 when I take negative 425 divided by 2. I have negative 2 1/8, or negative 2.125, or negative 2 1/8 plus 11. Okay, so what does that represent? Negative 2.125. What does that represent in the context of this problem? Think about that for a minute. Okay, remember, this is the change in y with respect to x. This is the change in the number of pounds of halibut I can get with respect to the number of pounds of shrimp I get. Okay, so basically for every pound of shrimp, for every pound of shrimp I get, I have to buy 2 1/8 pounds less of halibut. Okay, for every pound of shrimp I get, I can get 2 1/8 pounds less. Right? It's a negative slope of halibut. That makes sense, right? The more shrimp I buy, the less halibut I can buy, and it's by that much. So how many pounds of shrimp can you buy? If you need 1.5, your mom's like, listen, I need 1.5 pounds of halibut for my recipe. Okay, so let's put that in. So then I have 425x plus 2 times 1.5 pounds of halibut. Remember, y is the number of pounds of halibut, right? Equals 11. So 425x plus 2 times 1.5 is 3. I subtract 3. I have 425x equals 8. Divide 8 by 425. And you get 1. Divide 8 by 4.25, and you get 1.88. I'm going to change that to a fraction. 32 over 17. So by 1.88, it's a weird decimal here. So I'm putting 1.882. We want to be careful. We don't want to round, too close here, right? So I might even just say to the guy, give me 1 3/4 pounds, 1.75 pounds or something. I'll get as close to 1.88 as I can, whatever the guy will give me. Okay, and maybe he has a digital scale and he can give me 1.88. I don't know. But that's how many pounds I can get. Okay, it's a good way to know instead of be standing there at the cash register with not enough money, right? We've all been there, I'm sure. All right, the other part of this chapter is on direct variation. This is another application of slope-intercept form. A direct variation, guys, is a form of the slope-intercept equation that's just y equals mx. Okay, if something's in direct variation, it goes through 0, 0. It's just y equals mx. If you want, you can write y equals mx plus 0. Okay, so write and graph a direct variation equation that has negative 3, 2 on the graph. And that's all we know. But it's not all we know. Because they said direct variation, I know it goes through 0, 0. Okay. So it looks like I go down 2 over 3. My equation is y equals negative 2/3 x. I know it's plus 0.